In the present video, we'll be discussing about the manipulator kinematics. So in the manipulator kinematics, here you're going to tell how the link is, how the link works, how to name the different frames, how the manipulator kinematics has to be calculated, how the actuator space, joint space and Cartesian space is defined. So this you will see in detail. So what is a link? So link it is a set of bodies connected in a chain by joints. So the term here, and it is a lower pair. What we use the link, it's a lower pair. So it is a connection between the pair. The link description is being defined. So here you can see 6 possible lower pair joints. So it may be revolute, it may be prismatic, it may be cylindrical, it may be planar, it may be screw type, it may be spherical type. So what is this revolute type joint is? Here you can expect, as in the sketch what we see, here it has got a revolution which is going to happen with respect to the joint. So here if it is if you need a sliding joint, then prismatic type of joint is used. Then if you need further cylindrical motion, means this type of joint is used. If it is a planar joint on a flat plate, you can make the motion on the plate. So if it is screw type, there will be a screw on that. The washer or the bush type, what all you engage on the surface, that it makes the motion. So if it is a spherical motion, then it is going to have a spherical motion on the surface. So here link might be called as zeros and ones. 0 means it is fixed. If it is a moving body, means it is named as 1. So like this, in this 3 space, minimum 6 joints are required to define the motion. So typical manipulator may have 5 or 6 joints. So robots are not actually a single kinematic chain. They have a parallelogram linkages or other close kinematic structure. We'll consider one such manipulator which is designed with the help of robot in the present slide. So here you can see axis with respect to both the axis links are defined. Link I minus of 1 is at the center. So with respect to axis I, link is defined. So it is minus of 1. Further you can take link as I minus of 1. So based on the axis I and axis I minus of 1, link it is defined. So how the plus 1 or minus 1 is defined is based on the motion what take with a particular link. So there are 2 neighboring joints of a manipulator are present with respect to the rigid body, a link is considered. Here he shows the sketch of a simple link that supports the 2 revolute axes. So here he defines the distance and also defines both the bearings. So how the motion must happen inside the bearing, it is defined. So here to define the motion, DH convention is used, that is Dynamit-Hartenberg is considered. So standard naming for the linking, it is defined. So in the next video, we'll be discussing about the DH convention, what it is followed.